So guys, welcome to the next session. So we have seen two methods of working on the same CAD. Okay, this is the CAD which we are working on, and we have seen two methods how to work on it. The first method was part workbench. The second method was called closed body. Okay, so using surfacing, completely creating it using a closed body. Fine. So the third method would be using surfacing. Okay, but it is a mixture of surfacing and part design workbench. Fine. So let's start. Okay, I'm going to name it as a method 3. And yeah, as I said earlier, we're going to use the sketches from the previous constructions. Okay, we have the first sketch, and what I'm going to do is I'm going to do start with surfacing. Okay, I'm going to extrude it. Okay, and the next operation which I'm going to do is I'm going to create a top wall. So for that, I'm going to create a 0 point. And extrude it in X direction. What is the offset value of this? It is 30. Okay, so how do you know that if a surface is matching? Okay, so there are two surfaces here, right? So one being the top surface of the solid here, and we are creating another surface here, right? So how do you say that they are matching? Okay, so when you rotate and see, you can see both. Okay, so at one stage it will be overlapping with each other. So you can see gray and you can see the neutral color also. So that's how you say that those surfaces match with each other. Okay, so what I'm going to do now is I'm going to trim them. Okay, once this is done, I'm going to jump back into the solid workbench. But yeah, even before that I can work on fillets. I'll tell you what and why I am doing this. Once I've okay, you know the fillet value is R15. And the fillet value here is R3. Fine, so now I have the base. I'm going to put it in the new geometry set as base. Set a body. Okay, and jump back to the part workbench. And now you have another option called as thicken, right? So thicken surface is the one which I'm going to give, and it is an inside thickness. Okay, there are two directions of thickness. Okay, you can either thicken it inside from the surface, okay, or you can thicken it outside from the surface. So both ways you can do that. So here I'm going to go and thicken it inside because I am creating the outer surface. Let me change the color of this parent. Okay, now we can see, right, the surfaces are overlapping and they are matching. insert another geometrical set for bush 1. Okay, so now what I'm going to do is I'm going to make a sketch of the bush 1. Okay, and there's hole here, right? So I'm going to go back to surface design. Okay, here what I'll do is I'll extrude it. So you know that the top limit is 50. Yeah, and this other side it is 0. Okay, so now measure the thickness of this object. Okay, so what you can do is you can say surface 1D for both of them. Okay, so the thickness of the first bush is 23. So what I can do is I can give 23 mm thickness value for it. Okay, but even before that, what I'll do, I'll work on the second bush also, so that once I go to the part workbench, I can thicken both of them. Insert a geometrical set for bush 2. Okay, the thickness of this part is 15 mm. And yeah, for the bush 1 we'll extrude it so that we can split it later. Okay, so let's move to the part workbench now. And as I said, okay, so you would have known the working procedure here, right? The first command should always be a boolean. So what I do, I go right click here, insert in a new. So when you do that, okay, so this is not happening. So what I'll do, I'll insert another body and add the thicken object to it. Okay, so now what I have to do is I have to insert another body. Okay, so for the bush 1, I have to go thicken it. Okay, so there are a lot of jumping between workbenches, but yeah, in few OEMs they have both part and surface workbench assembled to in one single workbench. So they can customize it. So they can customize the workbench and then have one workbench for both of them, so that you don't have to juggle between workbenches. 23 mm is the value. I'll insert another body. $15 is the value for that. Okay, these are operations which you would be very familiar with, so you don't have to teach them. So a simple Boolean operation. So you've been very familiar with this by now, working on the Power workbench. Fine, we got both profiles, and now you have to create holes. Here is a command called split in Power workbench, where you can give surface or a plane as input to cut it. Okay, so which direction you want is decided by the arrow. So I want it on the other side. Sorry, it went wrong, please again. Okay, now we have to create a Counterbore hole here. So for that, what we can do is we can extrude surfaces. And yeah, I think we can do it in the bush tool only. We go to surface workbench. And yeah, in the push tool, I have two circles, right? So let's do that. I'll extrude both of them. And you know, from the top, it has a step of 5 mm. So it is 50 minus 5. It's 45 millimeters. So I'm going to trim them. Okay, I'll make it very clear for you. So the hole which is inside has to trim first with the surface. Say okay. So we get a profile like this. We get a profile like a T shape, right? So then comes the second extrude, and you have to chop the top wall of the T surface with this extrude. So once this is done, we can very well split it. Okay, what else is pending? We have to work on the bushes which are there on the outside. I'm going to rename it as fixing bushes. We'll change it into the correct channel, let us say. The height of it is is 35 mm. So we can correct that later. And now we can thicken it to a certain value and then finally do an unit turn. First thing is splitting it. Okay, so we want the surface which is outside, so we have done that. So you got a counterbore. So just overlap it so that I am very clear on what I am doing. And the next operation is the fixation bushes inside the body. Thicken it. I think what was the thickness of it? It's approximately good 5, and then measure it. Some 7 thick. Okay, so 7.5 thickness value I've given. So I'll put it in 4 portions, right? Okay, so what I'm going to do is I'm going to mirror it along. Does it explain? Okay, once that is done, so I'll mirror it with respect to the YZ plane. Okay, so now you have one object at 4 portions, right? So if you modify one, everything else will get updated. So what can we do here? We have to unit trim. Okay, so now say this is okay, so inside face did not get removed, so I'm going to do it again. You click on the faces which are inside. Fine, so what is pending? So you can create holes here, right? That we can do. Yeah, we have a sketch for that hole also. And I think we can do it in the bush itself. Yeah, I think we can name everything, so it's confusing for me. Very good working procedure is with naming. So you can see, right, there's something error happens. So it turned gray, and when I scroll zoom in, only the tree get modified. So what has happened is I've clicked on this line which is here. Okay, so when you click on it, or when you click on the compass which is there on the right side bottom, it will get grayed out. So you click on it once again and then it will work properly. To name it face, and yeah, the second object is bush 1, which is bush 2, and the last object is fixing bushes. Okay, there's something wrong which has happened. So you need the surface is there on the inside also, right? So I shouldn't have given the key edges. So what I'll do, I'll remove them and you only remove whatever is there inside, so it's working properly. So to go to the bush and create holes in it. whole command, and yeah. Okay, for the hole command to activate, you have to first click on the surface in which you're going to create the hole, and then you can give the sketch as an input. I'm going to take reference from this sketch. Okay, so once that is done, I'll go to the node show material mode, and yeah, position coincide these two together. Okay, so once it is coincided, you can come out, and yeah, pretty much all the dimensions are predefined as we worked on it earlier. Do a circular pattern, and I think we have the access system. Do we? Let's go check that. No, we don't have the access system, so we have to create it. Okay, it'll be there, and yeah, you can find it in the push option. Get back to the whole command, and yeah, do a circle pattern. Okay, so yeah, there's some thing which you have to consider here, because if you do a circular pattern, you should always give a proper input. Okay, so reference element is this, but it will always take as current solid. Okay, it means the thickness, the hole, and everything will get circular pattern. So you won't get any proper output. So go here and then say only hole to be circular pattern. Okay, so once that is done, you can give the chamfer. And as always, I can use the fillets at the last. So there's an overlap here, right? So we have solved it earlier. Okay, so what I want you to do is find a way to solve this. Okay, there's an overlap here. So how do you solve this overlap? Okay, so with your knowledge in part design, I would want you to solve this issue. Okay, I'm selecting all the edges which I want. We fillet it for 3 mm. So yeah, so we've got the output, and the only thing which you have to do is you have to solve this. Okay, so this is your next exercise. Okay, now we have seen 3 methods, right? So 3 methods on working on the same CAD. Okay, so which one do you find to be most appropriate? Okay, so when you ask me, you can either work on the the part workbench, but it is going to be a little bit a time-taking process. Okay, or you can work on the method 3, which is surfacing along with part. Okay, but I would not recommend you to work on the method 2, which is close body, for objects like this. Okay, so close body is for operations where you work on class A to class B and C. Okay, so this is an and solid which can be easily worked on part workbench. Okay, so you should always know which workbench you have to work on. So the reason why we worked on all 3 workbenches, right? So even the closed body workbench for an part design component. Okay, so the reason why we worked on all 3 workbenches is to do a trial and error and find which method is optimal for a specific CAD. Okay, so closed body type working might be very easy for some other objects, but for this specific CAD it is not advisable. Okay, but yeah, you work on all 3, do some trial and error, okay, do mistakes and then learn. Fine, so you would have worked on 3 different ways on working the same CAD. Okay, so in the next session, we're going to see about the advanced surfacing operations, and we'll be working on some simple exercises, then to a little bit more complex exercises. Thank you.